welcome on the webinar regarding the operating system 4.0 from IQRF. I'm Simon. I guess most of you know me pretty well. So as I said, we will go through, let's say, a theory about the new features of the operating system 4.0, and then I will show this to you in practice. You can jump in anytime, just throw your questions. This is absolutely not a problem. So there are not many people here. So if you don't understand anything or you want more details, please just stop me and ask your questions. So before we go to the key part of the presentation, which will be focused on the security, I will give you a couple of heads up regarding the operating system 4.0, like other features. So first of all, we implemented like very low power mode, deep sleep it's called, and it has a consumption less than 100 nanoamps, which really enables projects with very low power consumption. So then the battery operated devices can work for many years, depending on the application. Another new feature is that we extended the range of LP mode. That means that now the range is the same as for standard mode, and before it was like 60–70%. So that's a good progress. We also improved FRC. We added 1 byte in the package, so now we can download 1 byte from 63 nodes and 2 bytes from 31 nodes. We also change, thanks to the new operating system and the security, the system of, let's say, doing restore of devices. So now you don't have to do the cloning at all. So everything is based on the access password, and you don't have to go through the process of cloning, which was a little bit difficult, or it was a long procedure basically. Then also, like, we are cutting dead wood, let's say. So we canceled a DPA demo that was a special hardware profile that enabled only five nodes. So this is completely cut off right now, and also a special hardware profile that enabled like both coordinator and node at the same time. We scratched it out because nobody really used that, and it was just making confused. Also now, as of now, we don't support mesh networking without using the DPA. So the DPA is the only thing that we support if you want to use a mesh network. We put off the IQ mesh example from the startup package, and no one actually uses it in this time. For the programmers, a good note is that we changed the IQRF header file. So there's a change of the name. So basically, if you have a already custom handler written in your in C language, you have to change this header file. Also, in one network, you cannot use both operating system 4.0 and 3.08. On the other side, you can do the upgrade remotely over the air, so you can put the whole network on the last operating system. And also, you can do the upgrade from 3.08 to 4, but not backwards. And also, for this new operating system, you need the last IDE, and you need the last DPA. So those are the other features that are in the new operating system, and now we will focus on the security. So the complete security is based on the standard AES 128. There are basically 3 layers. The first layer is access encryption. So actually, to be able to join the network, you need a password, access password, and this is used for bonding. That means when you want to enter the network. The second one is CAT services. This means when you want to wirelessly get connected to already installed network. So you also need this access password. And the third thing is when you do the backup of the network and you want to do the restore, then you also need access password. So for example, for the backup and restore, you do the backup of your network, and you can take any module from your stock. You do the restore. With the restore, you need to know the access password, and then you can actually restore a coordinator or any module in the network or any node in the network. So even someone, if they, let's say, steal your backup file, they are not able to do the restore without knowing your access password. The second layer is networking encryption. So basically the communication in the network is fully encrypted, and then there's optionally user encryption. So basically you can encrypt your own data, so no one can read it, even us, like the manufacturer of the module. So now some general notes. So the compromising of keys is like very usually the security problem. So also operating system minimize completely the manipulation with the network and access keys, and actually the keys are generated from the passwords, and the passwords are generated randomly with high entropy. I will give you more details on this later on, and all the communication or the delivery of the keys and passwords is done already encrypted. So there's no unencrypted communication in the new version of the operating system. So the good thing about that is that you as a user, you work only with passwords and no keys. Also the keys are modified in the time, and they are modified by hash functions, and there is no direct relationship between passwords and keys. This means that also you cannot, if you actually, let's say, if you hack a key, if you get a key, you cannot use this key in another network, or you cannot use this key to find out the relationship between the password and the key. So the keys are generated dynamically. They are changed in time. And also, as I said, like the password, the relationship between passwords and keys are different in different networks. So then, even if you break one network, if you break one password or one key or both, you cannot get into another network. So then, if we go into the detail, the first is the access encryption. During the bonding, it's used in the way that you basically you have a coordinator and you have the node, right? And in order to enable them to communicate together, to set up a network together, both of these modules, both coordinator and the node, has to have the same access password. So this is what you put there in the configuration, or you can use also a C command. So basically they have the same access password, and during the bonding, when you, let's say, push the button on your node, the data, the bonding request is actually encrypted by the access password. You do the access key, and those encrypted data are sent into the coordinator. That means here, and here they are decrypted based on the same access password. So if you don't have the same access password here, you will not be able to bond that node. And then you do the bonding, or the coordinator does the bonding. It adds the logical address, and it also provides the data about the networking. So it sends in this package also the network key, and those data are encrypted and sent back to the node, and then they are again decrypted based on the AES 128 on the access password, and you have the device bonded. So the same principle is used during the bonding, during the CATs, and also during the restore. And as you saw on the presentation, the whole communication is already encrypted, so you don't send any keys, any data unencrypted. So this is based on AES-128 16-byte key, and as I mentioned, you can set up the access password in the TR configuration, or there's a new operating system function, set access password. So that's the access encryption. Then once you have the network set up, you are using, or the operating system is actually using the encryption of the networking. And actually, the thing is that you don't care about it at all. Again, it's based on AES-128 16-byte long keys, and there's even extra proprietary CDC algorithm. And actually, if you remember, before, the network ID was based on the module ID. Now it's changed. Every TR module from the factory has a unique and very random 192-bit password, and from this password there's a derivation which brings the 128-bit network key. Okay, and this is then used for the networking, and this is the thing which is distributed during the access, during the bonding. And then the network password is actually communicated to the nodes, and then it's used for the decryption and encryption of the communication in the network. So this is thing that you don't take care of at all. So this is done automatically with the operating system. So then the last layer is user encryption, and this is optional. Here you have a picture from the IQRF IDE. So here you set up the access password, and here you can set up your user key. And this is fully under your control. You can specify the key by yourself, and also you can do the encryption and decryption on the modules, like in the coordinator or in the nodes, or externally. That means that, for example, you can encrypt your data on your cloud. You can send the encrypted data from the cloud to the gateway, from the gateway to the coordinator, and then to the node. And for example, they could be decrypted on the module of the node. And the reason is that it's using a standard AES-128. And if you know the key on the module, and if you know the user key on your cloud, you can encrypt and decrypt it. Okay, so then the data on the whole way, they are fully encrypted. There are also new operating system functions linked to this. So you can set a user key, you can encrypt the buffer, you can decrypt the buffer. So then this is the picture how the packet looks like. So here inside you have the data. You can encrypt them with the user key by AES-128. Then you have some block checksums. You have the data, the whole packet. That means also like the logical address, the hardware profile ID, and so on and so on. All the information for the networking communication. This is all checked by the CRC16, and then the whole package is actually encrypted by the AES-128, and this is what is then sent out. Okay, so this is how it looks like, and here is a picture of the point that actually you can encrypt the data in the module or also outside. Okay, so for example, here you encrypt the data, let's say on the cloud. They are sent encrypted through the gateway to the coordinator. Here they are encrypted by the operating system, like completely encrypted for the networking communication. They are sent encrypted to the module. The module decrypt the networking communication, and then you can do the decryption of your RF buffer in the module or outside, for example, on your device. So both is possible. So just to summarize this, I went very briefly through that. If you have any questions, just let me know. I will do my best to answer them. I hope that Jarna Mastik is here or as well to give me some support on that. But basically, the important thing is that the complete security is done, or the encryption is done based on AES 128. It's used for the access, for the bonding, for the service mode, and for the restore of the coordinator or the nodes. Also, the networking communication is completely encrypted by IES 128, and also you can encrypt your own data. Okay, so this is basically very briefly the summary about the security, which is now integrated in the operating system. And please just let me know if you have any questions regarding that. Are there any questions? No, just you can interrupt me anytime. So before I jump into the, let's say, practical demonstration of that, I would like to invite you to the IQRF Summit. So it's in June 7th and 8th. On the June 6th, there will be a distributor meeting and also the Alliance meeting. So for those who are, let's say, Alliance members and distributors, you should be there also the June 6th. Our goal is to bring there like 200-300 participants. We have already 17 companies registered as partners, so there will be a number of presentations. There will be also a number of workshops, and there will be like a marketplace where the partners will show and demonstrate their hardware, their solutions. And one of the workshops that we are going to do will be based on this IoT Starter Kit. So this is a new product which is done together by MicroRisk and Ion. So basically it consists of this, I think, well-known IQRF module and evaluation boards, and those are the development boards with sensors, and this is with relay. And the thing is that very easily with this hardware and the software which is available on the GitHub, this is this IQRF daemon, which you download into this board. You will be able to create the whole IoT solution. So from the node, like actuator or sensors, wirelessly to the gateway. This daemon will provide you all the services connected for the IQRF, and also on the other side to connect to the internet for the UDP, TCP, and QTT. And also it will be able to connect to the different, let's say, clouds and services. So for example, Microsoft Azure will be there. ReHive Management System provides a solution how remotely control your gateway. So if you want to do any upgrade in the gateway, or if you want to see what the gateway is doing, yeah, you are able to do it with the system. And there are some also, for example, Resin this is a tool for deployment. So there will be like a growing number of services linked to this starter kit. So also you as a let's say as a provider or as an alliance member, you can add your service here. And on the other side, we will extend the number of end devices that you can connect here, because IQRF provides interoperability, and those end devices will be promoted and sold on the new shop. So we are now working on the platform, which will be it will be called IQRF.shop, and here on this shop you will be able to buy all interoperable products from all the alliance members. So for example, if you say, okay, I want to test something, you will be able to go to this shop and say, I will buy this gateway, I will buy this and this end devices, and they will be delivered to you. So this should enable to let's say to start up pilot projects very quickly, to test IQRF devices very quickly, and on the other side, for you who are manufacturers, it will enable to sell your devices to new potential customers, and like globally. So this could be pretty interesting thing. So by the way, for the workshop on the summit, you or your partners, your students will be able to register online for the summit and go to the eShop and preliminary order this kit and also the end devices. And then during the summit, there will be 2-day workshop how to make this IoT starter kit up and running, how to connect other end devices, how to use these services. So it will be very practical. And after 2 days, you will have a very clear picture how to work with this kit in the Internet of Things project, let's say. Here I added a couple of useful links, so where you can download the startup package, operating system, white paper, also where you can find the SDK. There are some new videos how to work with the new operating system, and there are some standard websites. And now I would like to show you in practice how you can do the basic things with the new operating system. So I will just jump into the IQRF IDE. Do you have any questions meanwhile before we start with this? No? All right. Just don't worry to interrupt. So what I'm going to show you is, first of all, I will share my webcam so that you can see that I'm doing the things really in real time. How do you get the links? It's a very good question. We will send out the presentation after the webinar, so you will get this in the PDF, and yeah, you can. So basically, you will get it through the email, and then it will be also on the Alliance website. So if you have any other question, just please ask. Okay, we will send it to you. Thank you very much for your email address. So first of all, what I will show is that I have here a module. If I plug it into the programmer, I push a Control M, and you will see that I have a operating system version 3.08, right? So the first thing what I need to do is to upgrade it to the operating system 4.0. It's very easy how to do that. I just push this button, which is a wizard for changing operating system. I will do it through the SPI, not wirelessly. I have this device connected, and now it detected operating system 3.08, and the new operating system will be 4.0. So now it just asked me a couple of times if I'm ready to do that, and now actually I started the process, and the new or the original operating system is now being upgraded to new operating system 4.0. By the way, what I have here, if you now watch the webcam, I have here two modules. They are not bonded, but they are already on the operating system 4.0. They are both nodes, and they have a custom handler for this end devices or end devices development kits. So on this development kit, there's a temperature, illumination sensor, and potentiometer, and here is a relay. So afterwards, what I'm going to do is, once I have this new module on the operating system 4.0, I will have to upload a hardware profile for the coordinator and for the coordinator, and also the configuration. So now you can see that the wizard went through successfully. So now I have the module on the operating system 4.0. If I push Control M, you can see here original operating system 3.08, and here's 4.0. So now I have a module on the new operating system, and I want to make him a coordinator, and also I want to set up the same configuration as is for the modules. So those are the, let's say, things that you already know. There are no big changes. What is the big change is that there is a new new page, let's say, where you can set up the access password. For the nodes that you can see here, I already set up the password IQRF. Okay, so now I will delete it here. So actually, I will put no password into the new coordinator. So I just close it, I save it, and I do the upload of the hardware profile and of the configuration. So now the hardware profile and the configuration is being uploaded. So now, because we have a different access password on the nodes and on the coordinator, I should not be able to bond the nodes. Okay, so now what you can see is that I have here one coordinator which is not bonded, and now I will try to bond node number 1. So I push the button here, and even if I push it a couple of times, you can see that the coordinator doesn't accept it because he has a different access password basically. So what I have to do, I have to change the configuration. So I will have to go here, I write IQRF, as you can see here, and I can upload it. By the way, here in the IDE, you can also protect this configuration. Okay, so I can also close this configuration, so it's encrypted. It's, I think, AES 256. So I can encrypt it, so no one actually can open my configuration and read this this password from the IDE. Okay, so I did the upload. I will again save the changes, and now I should be able to bond the node. So now coordinator is waiting for the bonding. If I push the button here, you see that now the bonding went successfully. So I can bond the node number 2, and this will be the same case. Yeah? So now we have 2 nodes bonded. I very quickly run discovery. Those are things I guess you already know, and I have a network up and running. Okay. If I have the network up and running, the next thing what I should do is to do the backup. Okay, so I can go here in the control into the backup, and I will back up the whole network. So basically, I download the information, not all the information that are in the coordinator, but the networking information. Okay, so now I have the information from the coordinator and about the whole network. I let's say save it as a webinar workshop number 3. I save it, and I've got it there. And now let's say that this module is actually broken, so I take it out and I put in another module. Okay, completely new one that you have on the stock, and just plug it in. It's there. I will double check what's the operating system running. There's operating system 4.0. That's fine. So the first thing what I need to do is to upload coordinator, hardware profile, and the same configuration. Okay. So I do the upload, and by the way, for this for the restore that I'm going to do later on, you need the access password again. So in order to make a in brackets clone, or like a copy of the original coordinator, you need the access password. Okay, so now I push the restore. I use this backup file, and now it asks me if I really want to change it, and if that it must contain the same access password. If I want to restore the data, and I put yes. Here I don't have to write in the same access password, because I didn't close the IDE and open it again. But now if I just restart the module, and I do the upload, you can see that we can see the very same picture, and I can just test it if actually the communication is working. So now I have a new module, and if I send the command, you can see that the red LEDs are switched on. You can also check it in the terminal log that the communication is working well. Okay, so in a couple of minutes I was able to do the backup and restore of the original coordinator. And this is, by the way, what could be done also in the real time. So for example, in some applications you can have one coordinator and the second one is like backed up in the real time. So if the first one doesn't work, the second one can immediately take over the control. Okay, so do you have any questions regarding this? Okay, if not, then I would show you the last thing. The last thing is that there are some new things in the CATS. So this is the CATS service tool. So from the previous coordinator, I will actually create the CATS, which is a service tool. So now I don't have a coordinator, but I have a service tool. The new thing what you can find here is an RF scanner. Okay, so you can just switch on RF scanner, and now the module is scanning the selected channels. As you know, we have 62 channels. So here you can set up the range from the channel number 0 to number 62. If I set it up and I go to the graph, now you can see that it's checking all the 62 channels. Here you can set up also a layer that can, for example, do a beep if it's over the limit. You can like freeze it and so on and so on. Now here you can see the maximums, by the way. Okay, so that's a new tool. By the way, the source code for this RF scanner is part of the startup package of the examples. So you can create a similar RF scanner into your system. So you don't have to use this one, but you can use that open source. So and the very last thing I want to show you is how to get connected to the module or to already installed device wirelessly through the service mode. So now again we are using access password. So if I don't use any access password, I push connect and I do a reset of the device. You can see that I cannot get connected. But if I put here access password IQRF like this, I hit connect and I reset a module. You see that I'm immediately connected, and now I can read all the information about the modules. And by the way, I can also do the wireless programming. I can unbond it. I can do the backup, and I can also do the restore. So here, for example, I can choose the backup file that we already used. Okay, and I can select which module I want to restore. So basically with these tools you can do a lot of things. It's already prepared, and as you can see, based on the access password, you can do the bonding, you can do this CAT service tool, and you can do also the restore. So those are the things that I wanted to show you very briefly, that you have it. So now you can have more questions. If you have any, was it clear at least a little bit? Does it all make sense? Hope I'm not alone here.
No, Simon, we're still with you.
Okay, thank you. Good to hear that, Hans Ole.
One question that came to my mind: new deep sleep mode. Is the transceiver still able to wake up on radio, or do you need an external interrupt?
Actually, it's not. It's not. All our sleep modes. From the sleep mode, you cannot be woken up by the radio. It's always by a pin. That's one option, or the second option is a watchdog.
Okay.
Yeah.
Good.
So not by radio.
I understand.
Okay, thank you for the question. Any other question? All right. If there's no other questions, so then I will thank you for your time. This is all I wanted to share with you.